Okay, friends, here is a video lesson on 3.5, which is on inverse trigonometric functions. So, down here we have this diagram. We have the domain of f. We take x into the function f. What comes out is f of x, which we name y. So this is what the function f does. The inverse function, which is called f inverse, takes in y and outputs x. So we have this relationship here. F of x equals y. That's the same thing as saying f inverse of y equals x. The inputs and outputs switch. Okay, so now we're going to talk about inverse functions of the trigonometric functions. So let's look right here at the graph of sine. This is the graph of sine. If I were to ask you, which angle measure has a sine of 0.5? Well, from this picture, we would have 2. Call that theta 1 and call this theta 2. So what does that 1/2 mean? That's my distance above my y value, right? That's my distance above the horizontal diameter, which is the y value. So this is 0.5. And so there are 2 points on this circle that have a distance above the horizontal diameter of 0.5. They are this angle measure, this guy is theta 1, and this angle measure. So this bigger one is theta 2. So looking at this question right here, which angle measure has a sine of 0.5, we can symbolize that as sine inverse of 0.5. Because if we remember the little diagram here, sine takes an angle measure in and spits out the distance above the horizontal diameter. So if we go in the other direction, if I give you the distance above and I'm looking for the angle measure, then that's sine inverse. So sine inverse of 0.5, well, I would have to write down theta 1 or theta 2. And that breaks my function criterion. The criterion to be a function says that every input has only one output. Okay? And you'll notice actually for every distance above the horizontal diameter, except this one or this one, there's going to be 2 different angle measures that satisfy that. So for instance, how about this guy? Well, we have this point and this point. How about this one? Well, we have this point and that point. And so what we do to get rid of this, ambiguity between having to pick between 2 angle measures, is we restrict the domain of sine. So we're actually only going to be concerned with angle measures along this half revolution, from what we can call negative pi halves up to pi halves. And we're only going to be concerned with this half of the circle. The reason we do that is because from negative pi halves to pi halves, we get every single possible distance from the horizontal diameter without repeating. So as I start my rotation down here and go along, we can see that we get -1, right? Like this point right here has a sign, uh, has a y value of -1, and as we march along the circle, we go from -1 to 0, and then from 0 up to 1. So we restrict the domain of sine to -pi-halves to pi-halves. Yeah, that's all I wanted to say there. So for cosine, same thing right here. Which points on our circle have a distance to the right equal to 0.5? So here's a distance to the right equal to 0.5. This point and this point have the same distance to the right. So what am I trying to say? They have the same cosine. So if I ask you cosine inverse of 0.5, well, I want to be able to pick only one of these. I want to be able to pick only one of these. So one of them is this angle measure 1, and the other is this angle measure, theta 2. So I want to be able to confidently say theta 1. So we do the same thing. We only consider a half of the revolutions. So in this case, for the cosine, we're going to consider the angle measures from 0 to pi. You can see that over here we have a distance to the right of 1, and as we march along the circle, we're going to decrease in our distance to the right all the way from 1 to 0, and then from here we go from 0 to -1. We'll do the same thing for tangent. So in this graph right here, which angle measure has a tangent of 1? So here is the line y equals x. Along the line y equals x, the slope is 1. And so this angle, which I will call theta 1, and this one, which I'll call theta 2, have the same tangent. So if I asked you, what is tangent inverse of 1, which means which angle has a tangent of 1, we want to be able to confidently say theta 1 only. And so just like the sine, we're going to take just the right half of the circle. But we run into a little bit of trouble because for this point and this point, there is no tangent. When you have a vertical line, the slope of a vertical line is undefined. Because we want change in y divided by change in x. Okay, so let's look at this line. Let's change from the top point to the bottom. What is the change in x? The change in x is 0. So change in y divided by 0, undefined. Vertical lines have an undefined slope. Horizontal lines have a slope of 0. So that being said, we are going to include in our restricted domain, to make sure that our functions are now 1 to 1, we're going to include every rotation from -pi-halves to pi-halves, but we're going to exclude -pi-halves and pi-halves. So we're going to talk through all of that one more time. Sine takes as its input an angle measure and outputs the distance above the horizontal diameter. So the inverse of sine is going to input that distance and output an angle measure. So looking at this point right here, we can give it some coordinates. The distance to the right is about 0.5, and my distance above, well, what percentage of the way there would you say this is? Something like 0.8? Okay, something like that. So I can say here that sine, I don't know why it keeps moving my ink. I can say sine inverse of 0.8 is this angle measure right here. Let me pause the video and get back into it to adjust this inking settings. Okay, I think we're back. Yeah, so the big idea here is that we're going to restrict the domain of the sine to negative pi halves to pi halves, including both, right? Because I want to get my negative 1 and 1 for the distance above. And if I restrict the domain of sine, then we get an inverse, right? If we'd restrict this domain, then we pass the horizontal line test, and we now have an inverse that is a function. And so sine, our special sign that is now restricted, is going to take these angle measures from negative pi halves to pi halves, including both the endpoints, and spit out a distance above. Well, my smallest distance I can be is 1 below, and my biggest distance above is 1. So the other function, the inverse, right, its domain is now going to be these numbers, and the range will be these. With cosine, the biggest distance to the right is over here at 1 to the right. The smallest distance to the right is here at negative 1 to the right. And so my domain and range of cosine are going to be similar to before, right? We had distance to the right. So the interval here will be from negative 1 to 1 for my distances to the right. And my angles, well, we went from 0 to pi. So this is my domain and range for cosine. If we're going in the other direction, the domain and range switch for the inverse function. For tangent, it's the same thing. Let's look at what happens as we get close to pi halves. So as these rays get closer and closer to this vertical ray right here, the slope increases. So we're going to say as theta approaches pi halves, the slope of the terminal ray approaches, well, the slope of the terminal ray, which is the tangent, approaches positive infinity. The slope just gets steeper and steeper and steeper. The same thing is true in the other direction. As I approach negative pi halves, the slope just gets more negative. As theta approaches negative pi halves, my slope, the tangent, gets more and more negative. And so in the diagram right here, the domain of the restricted domain is going to be from negative pi halves to pi halves, excluding both. We'll be very clear about that because you cannot take this, the slope. The slope of a vertical line does not exist. Right, so this is my tangent function. We input angle measures, we get out a slope. The set of all possible slopes is from negative infinity to infinity, right? We get all possible slopes as our tangent, as the terminal ray rotates from bottom to top. So we can see here that tangent inverse has this domain from negative infinity to infinity, and that restricted range right there. Okay. So let's look at some examples here. Calculate the following. Sine inverse of 1/2. Okay, so we have a reminder right here. Sine of theta equals the distance above. That means sine inverse of the distance above is the angle measure. So what they're saying is find the angle that gives me a sine of 1/2. So if you see sine inverse of 1/2, we know this is an angle measure. So that means sine of that angle measure is 1/2. So here is a point that I've drawn in my circle, and I'm only looking at this side, right? This point over here, right, that also has a sine of 1/2, but it's outside of my domain when I'm talking about the restricted domain of sine. So I have this label here. The distance to the right is long. The distance above is short, as illustrated by this triangle. So I've got √3/2, and there's my 1/2, right? There's that 1/2, which is the y value. So this angle measure here, right? I just have to decide between that point and this point as far as which one is pi6, which one is pi3. Pi6 is the smaller one, right? So we have pi6. All right. This guy right here. Arcsine is another way of writing sine inverse. Arcsine of 1/3. Okay, we know that is an angle measure. What that means is that sine of that angle is 1/3. So yes, we're concerned here with which angle gives me a sine of 1/3. But this number right here is not a unit circle value, right? It's not, this is not 1/2, √3/2, √2/2, etc., right? It's not in our unit circle. So that's kind of a hint for us, because we're not actually concerned with what this angle measure is. What we want is the tangent of that angle measure. And so this is kind of a really nice and helpful trick. What we can do is draw a triangle, a right triangle. And we label this guy theta. So we know that sine of that angle measure is 1/3. Okay, so probably you remember this. We have so, ka, toa. This is a way to kind of quickly remember our right triangle trigonometry. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if the sine is 1/3, then the opposite is 1, and the hypotenuse is 3. So let's call this guy x right here. We know that x squared plus 1 squared is 3 squared by the Pythagorean theorem. So x squared is going to be 4 minus 1, which is 3. Yeah, so on the right we have, oh, sorry, not 4. I'm going a little bit too fast. I'm so sorry. X squared plus 1 equals 9. So x squared equals 8. And oops, whoa. And thus x is plus or minus square root of 8. 8 we can write as 4 times 2. And so square root of 8 is square root of 4 times 2. So this is square root of 4 times square root of 2. So this is 2 square root of 2. So we get x is plus or minus 2 square root of 2. In our diagram, we're only concerned with a positive x value, so we'll just use that positive one. So we can redraw the diagram. And now what we're looking for is tangent of theta. So this is my opposite over adjacent, and that's going to be 1 over 2 square root of 2, which is our final answer. But if you like, we can rewrite that as 1 times square root of 2 over 2 square root of 2 times square root of 2, right? Just multiplying by square root of 2 on the top and the bottom. And so we have square root of 2 over 4 is another form of the final answer. I think this video is getting long. Let's pause it right here and we'll start the next one.